Hey everybody, hey. Welcome. Welcome to 33 Acres Brewery, where we have this epic opportunity to be with Dr. Gavin Wood. And how nice of you to be here in Vancouver, Gav.
Lovely to be here, Jay.
Very nice, very nice. How long do we have you? Like 40 minutes and then you have to go, right?
Uh-huh. Yes.
Okay, so maybe we'll do a little Q&A and whatnot. It could be pretty cool. But real quick, where's Lucy? Lucy, come over here. All right, everybody. Lucy's going to introduce herself and tell us why we're here.
Okay, hi. I am Lucy. I've been part of Polkadot ecosystem for about 3 years and recently have been a big part of spearheading the Polkadot Ambassador Fellowship. So in a chaotic, decentralized world, which we are in, the Ambassador Fellowship is there to bring the community together under one sort of umbrella and provide a platform and legitimacy for those agents that aren't tied to projects and they're just working with Polkadot for Polkadot. And so that's what we kicked off a couple of weeks ago. We were voted in by the community through our open governance system. We are 170 people at the moment. We're looking to grow that into the thousands. And one of our big targets is to hit 10,000 meetups a month across the globe. And this is our inaugural event. And Gavin is going to, he won't be at every one, but might pop up, and nor will I, but he might pop up every now and again, but that's what we're here to do. We're here to kind of revitalize the Polkadot community, and just in a week getting 35, 40 people here in a community that hasn't had a Polkadot meetup in a long time, I think means that we're in for a pretty cool ride. So, yeah.
All right. Thank you, Lucy. Thank you. And my name is Jay Tirana. I'm the director of a media company called the Kus. Polkadot is our sole and slightly chaotic client. We serve information services to the ecosystem. We're funded by the Treasury as well. And this is Dr. Gavin Wood. He's the founder of Ethereum and Polkadot. The way I explain it to people, and maybe it's time to correct me if I'm wrong, but I say we took Vitalik's idea and you actually made it work. Is that accurate?
Well, I don't know. I mean, I would say it was a shared idea. So when Vitalik came, if you go back to like October, November 2013, and you look at like the original Ethereum white paper, like before I had like my grubby fingers on it.
Okay, yeah. What was that?
It looked a lot more like a scriptable, like a betterly scriptable version of Bitcoin.
Huh.
Right. Indeed, EVM was called EtherScript.
Huh.
There was no affordance for like this object model environment that became like Ethereum's mainstay smart contract environment. Rather, I mean, this will seem a very technical point, and I kind of hate to have to bring it up with a non-technical audience, but it's a very important one. If you rewind pre-December 2013, Vitalik's white paper had smart contracts able to send messages to each other, but very, very crucially, those messages were not delivered immediately. Waited till the end of the block, and then it delivered them. What this meant is that smart contracts couldn't receive a return value. Like, it wasn't synchronous.
Huh.
And one of the very, very important elements that we see in Ethereum and all of the other smart contract stuff is synchronous composability.
Right.
The ability for one smart contract to query another one and get a result back immediately, right? And that was something that, in actuality, I accidentally brought to Ethereum. I misread Vitalik's white paper.
I see. You're like,
right?
This is how it should be, right? Obviously.
And I just coded it like
I
I would have thought it would be sensible to code it.
Yeah.
And Vitalik sort of came back and because there was a mismatch in our implementations, his and Jeff's did one thing and mine did another thing.
Gotcha.
And it was like, well, actually, hold on, isn't what mine does kind of better? And oh, yeah, no, it was not what I thought, but yeah, maybe. And then in the end, we sort of went with my way of doing things, and synchronous composability became the thing, right?
Yeah.
But yeah, I mean, I would say that calling it Vitalik's idea, yeah, I mean, sure, Vitalik wrote the original white paper, and certainly it stemmed from that, just as Vitalik's white paper stemmed from the Bitcoin white paper. But Ethereum, as it was delivered in whenever, July, August 2015, had fairly substantial portions that were there from me.
I love that. Thank you for clearing that up. Synchronous composability is actually another big issue, something you're attacking with Jam. We're going to speed run this whole thing. But maybe real quick we could talk about why you left Ethereum to make Polkadot.
Yeah?
Yeah, what was that about?
I don't know. People keep asking me this.
Get only as deep as you want.
Why did I leave Ethereum? I mean, there's a few reasons behind it. Some of them are like, you know, sadly reflect the political realities of human organizations with a lot of money at stake.
Sure.
But one of the most important ones is that I feel most comfortable building stuff, not maintaining stuff. And Ethereum was moving into, even back then, I mean, when we look at it now, we kind of realize, oh yeah, obvious. But even back then, close after launch, it was moving into a very much maintenance mode. Like, don't change too much, be very risk averse. It was dealing with an organization that was we were attempting to kind of keep people and not, you know, kind of rock the boat too much.
Are you talking about the Ethereum Foundation?
The Ethereum Foundation, its various offshoots, like, you know, it had a few subsidiaries, and not so much legal, but kind of in terms of organizational subsidiaries. Like, so for example, the Go Ethereum crew were a very different team to the C++ Ethereum crew, and there was some friction between them. Vitalik was kind of doing his own thing, and it was a politically difficult organization to navigate, and this really detracts from the ability to, like, you know, be creative and just, you know, envision and build. You're constantly, you know, shackled, and for some this is fine. Some people you know, thrive in this environment and they still manage to be productive within these constraints, but for me personally, I'm very much more I prefer to have a freer, clearer drawing board on which to create.
You for a while you created in parallel at Ethereum. You had your own organization, Parity.
Yeah.
And
Ethcore at the time.
Excuse me.
Parity actually changed its name to its Ethereum implementation's name.
Oh,
funnily
really?
enough.
Okay. But at a certain point you thought, okay, this isn't going to work. Obviously there's roadblocks. We're seeing those roadblocks today, right? We're seeing roadblocks with scaling. We're seeing roadblocks with organization. I think, like Vitalik just said, I'm going to take over EF, and did you see this? Did you see this? Again.
I thought it wasn't he the guy that, I don't know.
No, wait, did you see that last week?
Oh yeah?
Yeah.
This was in response to someone else saying, I'm going to make a new Ethereum Foundation.
Something like this, yeah.
Okay.
Yeah, he's like, no, this is how it's going to work. I'm going to take it over.
All right, well, you know, fair dues. I mean,
okay,
you know,
yeah.
Go, Vitalik.
So you wanted to create, eventually you created Polkadot, which solved a few of these problems. First of all, you had this vision for decentralized governance, which you implemented. Now, we just crossed 1,300 public refs. Anybody with DOT can suggest how to spend the treasury. Anybody with DOT can suggest how to upgrade the network. And anybody with DOT can vote on whether those ideas are good.
Yep.
This is happening today.
Yep.
And we have 1,400, I think we just crossed. 1,400.
Yep.
So there's that aspect. And then you were also attacking scalability, which you went in this direction of sharding with a bit of a flair, heterogeneous sharding. Each shard can be domain specific. this was your vision, and how do you think it's going? Or how do you think it went so far?
I think we achieved what I set out to achieve.
Yeah.
This is good.
Yeah.
Like, if you rewind to like late 2016, Polkadot Whitepaper, like, it's there. Hurrah!
It is, I know, yeah.
We did it.
Yeah.
Now, inevitably with technological development, you do something, you see it, you learn your lesson about like what could be done better. You have more data, right? And you data-driven development. You alter your strategy accordingly, and that's basically the premise of Jam, right? But yeah, when Vitalik and I were discussing, like back in 2015-ish, about what Ethereum 2 was going to look like, I mean it was a bit like Polkadot, right?
Mm-hmm.
I mean, not entirely. The heterogeneous thing was something that I brought along. Like back then, it was like, yeah, well, it'll just all be EVM, obviously.
Sure, yeah.
But yeah, a lot of it, the concept of like there being shards and there being them being separate and them being having their own subset of validators. This is all like fairly uncontroversial scaling tactics.
Yeah.
Now the funny thing is that we just went off and designed it and audited it and built it and finessed it and deployed it, and here we are. And Ethereum, I don't know, went off.
Well, it was kind of interesting because Polkadot's led on the technology front, but the idea of sharding has been obviously approached by Ethereum with L2s. The language changed. We started calling them L2s. Hey, all right, just for a moment I'm here. So this language of roll-ups came in. Today, on our media organization, I mentioned the Kus.
Yeah.
We released this chart where we pointed out, we discovered, that if you organize all the roll-ups in the industry by transaction count, of the top 20 roll-ups, 10 of them, 50%, are actually hosted on Polkadot today. Mm-hmm. And the crazy thing is that... Yeah, what? yeah.
Get on Twitter.
Get on Twitter. Follow the Kus. So if you organize roll-ups across the industry by transaction volume, by transaction count, 7 days, 30 days, whatever you want to do, half of the top 20 are hosted on Polkadot today.
Do you have a source on this?
Yeah, Token Terminal is the source.
Perfect.
Yeah, you can check it out.
Name a couple of them?
Yeah. So this is what I wanted. This is what I wanted to tell Gav about, because Gav is like on the cutting edge of blockchain. I don't even think he fully comprehends what's being built on Polkadot today, and I want to share some of those with him today. So the Polkadot's biggest roll-up by transaction count is frequency, and they have like something like 3.1 million transactions in the last.
Not Ethereum rollups.
No, all roll-ups. So Polkadot is also a roll-up. Yeah. Polkadot is also like a hub and roll-up. Yeah. So one thing we have is frequency. Mm-hmm. They have like 3.1 million a month or something like that.
Yep.
They're doing social media ID and graphs. Frequency is also, the people behind it are front runners for this. I don't know if you heard, but TikTok needs to be sold.
I heard.
Yeah. So they're front runners for actually purchasing TikTok, where they would put all those accounts on the frequency rollup.
Oh, I heard Elon was a front runner.
Elon is not a front runner. He denied. Yeah.
Right.
So that's something. Another top one is Mythical Games.
Yep.
So they have massive volume. Right now they have an NFL branded game in the App Store. They're about to do Pudgy Penguins game. All that is going to be on Polkadot. Nitro Nation World Tour is the next game that comes on. The last version of that mobile game had 100 million unique players. And then this summer, a FIFA branded mobile game is coming on. Did you hear that?
I did.
They've been, of course, offered to go, I believe, to other blockchains, but the fact is that they actually can't go anywhere else. You can't handle hundreds of millions of players anywhere else.
No.
So that's happening on Polkadot as well.
Yes.
And then what else do we have? Not launched yet, but Mandala Chain is backed by the Indonesian government. 130 million citizens. their IDs, their banking transactions, healthcare records. I went over there. I interviewed members of the government. They think blockchain is going to solve all their problems, and it will solve many. That's another roll-up that's coming onto Polkadot.
Peak.
Peak! Oh my God. Deep in projects, leaving all the other chains where they can't really do anything. They're all coming. What did they put in the last month? They just launched. I think they have 1 million machines already on chain. Peak is crazy. This is all happening on Polkadot today in your sharded blockchain system.
Works a bit,
Works a bit. All that being said, it isn't perfect. You've identified some problems with the system that you're working on. What are the problems with the sharded system that you're focused on right now?
So primarily it's coherency.
Coherency.
Yeah.
What does this mean?
As you scale a system, any system, the bits of it become farther apart because you're growing it, right? The size is increasing.
Yeah. Oh, I see.
Yeah, and this is the case for physical systems just as much as information systems. I mean, the physical world is still a world of information.
Huh.
And the issue is that as things become farther apart, they become less coherent. Like, some things affect other things more than still other things, because the distances are different. If everything is more or less the same distance away from everything else, then it's not a problem. Like if the system is small, as it gets bigger, it becomes very problematic.
So you and I here, we're pretty coherent, but if you were on that corner of the street, I was on the other corner of the street, coherency would diminish.
Especially if there were if everyone were in different corners of the various streets of Vancouver.
Yes, yeah.
It would become like a kind of, I'd shout to you and you might hear it, or maybe you wouldn't. You'd be like, what? And I'd be like, oh, yeah. And eventually you'd hear it, and then you might shout to like someone else.
Yes, yeah.
On your next street corner. But it would be different people would all have a different idea about what the conversation was at, right?
Yeah, yeah.
And this is a problem. Whereas if we're all in the same room, we all have basically the same idea of the conversation, except for maybe a couple of people that don't understand what the last thing I said was. It's the same with blockchain systems. As you grow them, coherence reduces. And when you have reduced coherence, it's a lot harder to build applications that span across like different use cases, different portions, different data sets, different sets of people, different sets of identities. It all becomes a lot harder because you have this growing population and you have to kind of cat herd them into one place whenever you want to have everyone be on the same page. Now, the way that we did this in Polkadot was we said, right, well, we'll have an automatic cat herding per parachain, right? So every parachain is always on the same page. But to get between parachains, that requires quite a lot of effort, and that's why we invented XCM, right? And XCM is this language for getting, and its associated data transport mechanisms for getting between the parachains, getting not exactly different parachains on the same page, but at least letting them communicate, like hollering across street corners.
Yeah. So when you say parachain, it's kind of like a roll-up. It's kind of like a little city. Every city is coherent in itself,
Right.
and then there's these highways between each city.
Right.
A little bit of a time delay, but we can communicate. Yeah.
Precisely. And back in blockchain world of 2016, this seemed like a perfectly reasonable trade-off to get significant amounts of scale.
No doubt.
But fast forward to today, and it's kind of okay, and we see what is possible with it. But to move on to the next chapter for like scaling big applications, we want something a bit more flexible with how we manage our coherence at scale, and that's really what Jam provides.
Okay. So right now we have these kind of rigid boundaries between each roll-up, but Jam is how does this change?
It relaxes these rigid boundaries. It doesn't remove them. There's no big answer to scaling something substantially and trying to maintain coherence. Like it's just a physical reality. If you scale a system, it will become less coherent.
Yeah. Sure.
But there are ways of pushing the boundaries of how coherent you can make it as you scale, and how little you can relax and where you can relax so that it doesn't really matter that it's less coherent in those places. And that's really what Jam facilitates. It's like, yeah, it's not going to be perfectly coherent, but it will be coherent in the way that you need.
Coherence where it matters.
Right.
Yeah,
and it won't be such a fixed immovable and inflexible, rigid means of policing the different the incoherence, right? It will be able to flow according to what the use case needs at the time that it needs it. What this means is that if you've got a smart contract on, I don't know, Akala, and you want to interact with a smart contract on Asset Hub, at the moment those smart contracts have to communicate through XCM, right? And that's asynchronous. It takes some time. It's costly potentially. With Jam, the idea is that you can still have like conceptually Asset Hub and Akala, but the smart contracts that exist in each can be moved around fluidly, so that if they need to live next to each other for a particular period of time, because it turns out they're doing a lot of interactions and we just want them to be really close to each other, they can be. And then if at some point later we want the smart contracts to kind of float around elsewhere, then that's fine as well.
Now listen, I want to save some time for 2 to 3 epic questions from the audience, so I hope everybody's thinking of something great to ask Gav while we have him here. But I just wanted to point out real quick, your approach for creating Jam, which is kind of like the successor of Polkadot. It's going to house not only Polkadot, but other services as well, we're calling them. But the way you're approaching this is really interesting. You've written the gray paper, which is all math. I think you've used alphabets from languages that don't even
There's
exist.
some English in there as well.
If I squint, I can see some English, but it's pretty incredible. And what you have is I think the largest technical prize in history, possibly, or something like
possibly.
this.
At times it has been 100.
It's in DOT and KSM. It's 160 million sometimes, something like that. Is it that high?
It
Doesn't
might
matter.
have hit that high at some
Once
point.
you cross 50 million, it doesn't matter. People are taking whatever language they're familiar with and taking your math and they're implementing it. And this is your approach. How many teams do you have doing this so far?
35.
35 teams. And there's like phase, what are you calling it? Milestone 1.
That's right. Yeah.
How many are looking like they're going to actually be able to implement milestone 1 here?
I mean, I think they're all really aiming for milestone 1. Some of them some of them have their sights set on going all the way.
All the way, yeah.
But I think a good few are really just trying to get to milestone 1.
Nice, get to first base. Yeah, that's awesome. Exciting stuff. Thank you, Gav, for this overview. I want to open it up to some questions because, oh my God, look, we have one right away. Come on over here. Come on, sit next to me.
I had like tons of questions, but I'm just going to ask.
You have one question.
Yeah.
There you
So
go.
I just want to say the last.
Introduce yourself.
I'm Sukhmeet. I'm from Few. It's a homophone on the word few, so we have power of few. We have 14 people team out of Toronto. We just flew to meet this guy. Right. So that's all the introduction right now.
That's great. Yeah.
Yeah. But the question that I have in mind is I actually forgot about it. Just kidding. The gray paper is like if you have a version of it. My question starts from, if Nakamoto was to come, nobody knows who Nakamoto is. So would your version of, if you were talking to him, how would you say, did you do, it's like the first part of the discussion was, did you do this or blah, blah, blah from Ethereum? No, I think whatever Ilure learned from any other mathematician before him does not make him bad or good. It just is that he was talented, same thing as you. So if Nakamoto was to come, what would he think about Polkadot and Jam? Is that something?
That's nice. What would Nakamoto think of Polkadot and Jam? All right. Thanks for starting us off easy. Go ahead, guys.
Well, I don't know Satoshi Nakamoto socially, so
He's my best friend.
I'm not sure I could really speak for him or her. I mean,
You can think about
I haven't really read the Bitcoin white paper recently, and when I did flick through it, I can't really say I was like, really studying it in depth. My understanding is that the Bitcoin white paper basically goes over the theory of the Bitcoin protocol, but doesn't provide a formal specification of it. Would Nakamoto be interested in the fact that it specifies a formal description of the protocol? Maybe. I mean, the fact that he wrote a paper at all, rather than just coded the software, suggests that this is sort of a direction that he might have felt was interesting. And apologies for the gender. I'm just being lazy. They might have felt was interesting. Yeah. I mean, it's really hard. I would say, look, I'm going to take an optimistic approach and say, look, they made a stab, right? They had a good go at it. They provided an idea that they coded up, and it kind of worked. And of course, they're going to be interested in stuff that takes that idea and runs with it and makes other more interesting stuff with it. That's going to be my answer. But I'm also a bit of a cynic, so I'm not sure if I really trust that answer. But yeah, fuck it. That's my answer.
I wonder if what they do think or what they would have thought about, because they built this universal computer. I mean, they've built this universal accountant, this universal calculator, sort of, and now this general purpose universal machine that we're building now, not only in Polkadot but in other places as well, attempting to.
Yeah.
This is really next level.
Yeah, I mean, so if you look at like the Bitcoin diehards, the maxis, they're like, oh no, obviously Satoshi would only have ever wanted Bitcoin to be exactly what he launched it as, plus the small changes that we've made. And I don't know. I mean, as a technologist, I did stuff for my PhD, and I'm pretty proud of it. But I wouldn't want to suggest that like someone shouldn't take that and run with it and make it better.
Yeah.
Right, and do more stuff with it. I mean, I don't want to prejudice it against saying that the original thing wasn't good as well, but it's just it's human development. It's like we take ideas and we, use them for other things. We improve on them. We expand them. We riff on them. Right? It's just part of the whole deal of like life.
Do you hold Bitcoin?
I do.
Yeah, nice.
I mean, not in a not as much as I hold certain other cryptocurrencies. But yeah, I hold a bit of Bitcoin.
That's
sure, why
nice.
not?
That's nice. You live on the Bitcoin standard?
The Bitcoin what?
The Bitcoin standard.
What's the Bitcoin
Oh,
standard?
you measure everything against Bitcoin.
Oh, I don't do that on a day-to-day basis.
Yeah.
I don't follow markets on day-to-day basis.
Hey, another question. Right back here. Come on, sir. Yes, please.
Perfect.
Have a seat. Please introduce yourself.
Hello,
One
Gavin.
question.
Yeah, perfect. Gavin, I'm Tangle. Nice to meet you.
Hey, Tangle.
Yeah, thanks for coming out tonight and sharing all this. Thanks to Jose for kind of bringing this in. Okay, question from some more of the technical side. So how does Jam compare to a traditional rollup architecture, and how does it verify and update state across shards, parachains, and manage synchronous composability?
All right.
Damn.
That's a fairly in-depth
It is.
question. Well,
Do we have the gray paper?
so firstly, parachains. That terminology is it's not like a first-class citizen for Jam, right?
Okay.
In Jam terms, parachains don't really exist. They are part of the terminology that we'd use for a service that sits on Jam. So Jam doesn't like deal with parachains. Jam
Okay.
deals with services, and then a Jam service like the parachain service or whatever would deal with parachains. Okay, so the rest of it. Synchronous composability. Well, Jam doesn't really deal directly with this either, but it provides primitives by which you could create synchronous composability in a fairly agile way. What Jam provides is a computation environment that goes well beyond what blockchains thus far have attempted to provide, at least in a unified way, including Polkadot. But Polkadot's underlying architecture is really helpful for doing this. How do we compare it to other rollup designs? Well, Polkadot uses elves, or cynical rollups, as I call it, which basically now Ethereum's optimistic rollups are not optimistic rollups. This is a misnomer. They are pessimistic rollups.
Sure. Okay.
Right? They assume the worst. Yeah, and only when the worst seems unthinkable do they move on and finalize. Yeah, so like forget like this whole optimistic thing. Just good marketing. Good marketing, bad description. Now, if you think that Ethereum's rollups are optimistic rollups, well, if you switch that to pessimistic rollups, then Polkadot's cynical rollups seem pretty good, right? Because cynical is better than pessimist. Pessimist is just the outright always thinking the worst.
So how are you putting cynical in? How are you like putting this as cynical as compared to optimistic?
Well,
or what do you, how do you?
They're cynical as in they're realistic about the world and the fact that they're in the wild, but they're not pessimistic in that they always assume the worst.
Okay.
Right? They're cynical as in they assume the correct thing. But they're not optimistic in that they're, just floating around. Haha, everyone's really happy and nice and no one's going to attack me. Everyone's just like, unicorns vomiting rainbows. We're not optimistic rollups. That would be optimistic rollups. Insecure rollups, right? Instead, we are cynical rollups. We assume the world is what it is, but we do our best to manage it. How does it compare? Well,
And verifying the data proofs. How does that work as well?
in verifying the data proofs, well, okay, so Jam's means of scale, which is basically its roll-up design, is the same as Polkadot's roll-up design, more or less. It's all based on the Elves research paper by the Web3 Foundation, which is the basis of cynical rollups, which is essentially the best means of scaling any blockchain system has thus far expressed, right? It blows ZK out of the water in terms of computation cost,
Can you
right?
just answer the question instead of dancing around the definition of words?
Well, I'm not really sure what the question is. It's like, what, you want to rephrase the question?
I'm not super technical. I'm just up here to ask the super technical questions.
Okay,
And
well-
that's where I don't know that we're getting the answers that we're looking for, and maybe that's okay if we don't get it tonight. No big deal.
You want to rephrase the question? Maybe I can.
Is there any way we can rephrase the question? I'm happy to just speak it out.
Can I help you?
Yes.
No, I guess it's just like curious to understand, right? Like between the parent chains or between like rollups generally, like in order to like verify that what occurred on the thing that occurred, there's some kind of proof verification system, at least typically in like Ethereum land or Celestial land, right? So you have like optimistic proof or a ZK proof that says, hey, this
No,
is good.
that's not the question.
So this I'm trying to like
No, it's wrong explanation.
No, that
what
is
he's
not the
saying
wrong
is,
explanation,
So
sir.
if the data group being the context of the data group, and it is actually mentioned in the section 3 to 5 of his paper.
No, I just want to understand, or we just want to understand,
I
like
know.
in addition, in opposition of this, which is how it functions in other
I know,
rollup
I know, I'm-
systems.
Hold on.
How does it function with Jam and the parachains? How do they communicate? How do they enable synchronous composability while verifying that all the information that happened across all the different parachains is in fact correct and true?
Yeah. So
Okay. I mean, look.
All right, hold on.
So you've got a lot of different concepts here muddled together. Celestia doesn't do correctness verification.
No, I
It provides
understand that.
distributed
I'm saying that
availability.
other people provide ZK
Um,
proofs in an independent rollup. I'm not suggesting this is what Celestia verifies. just saying.
Well, you mentioned it as an
I
example.
said Celestia land and Ethereum land, other places where rollups exist and provide some kind of
Celestia,
execution.
there are no rollups in
There are
Celestia.
rollups.
It's a data availability system
Correct.
only.
Theoretically, though, however, the rollups will verify their proofs and able to pass that information to other rollups. I understand Celestia is just a data availability network and has no execution. So forget the Celestia.
Uh-huh.
I'm just trying to understand how the parachains communicate their data and verify that data between them. That's it.
So this is all looked after. I mean, it's if you want the deep answer, elves. Just read the elves paper, right? This is like cynical rollups on Polkadot, as I just answered. Yeah.
I'm just not. I don't understand how cynical rollups work. That's all I'm trying to
Okay. Well, cynical rollups. If you want to, I mean, elves is the best place to read about this. You can also read about it in the various sections of the grey paper, including auditing. But on a summary level, validators are tasked with self-selecting in a cryptographically random manner the various reports of execution that the input data to the chain has been distilled into, and reevaluate those reports themselves and report themselves on any apparently invalid computations. This is different to fraud proofs because they're proactive. Fraud proofs are reactive, like they're passive.
So it's like validators on the main chain are verifying the data that's brought to them from the parachains. That's what I understand?
Well, there's a combination, right? Validators are both tasked with the provision of essentially staked guarantees of particular computational correctness. They're also tasked with data availability so that other validators can retrieve that data and audit those reports. It's a coherent system, right?
Is it somehow like a comparable to like a base rollup, perhaps?
No. I mean, you can compare it to any rollup in that a rollup is really just the case of registering computation into a sort of parent system. And specifically the results of computation, right? The effects of computation. And that's what we do here, right? So Polkadot is, one of the ways I've described it in the past is, it's a rollup host, right? It doesn't, the validators are the rollup sort of executors, the guarantors, the availability assurers, and the auditors, right? They do everything. It's all bundled together. If you want to know the specific mechanism, I mean, there's a lot of game theory behind it, but it's a little bit like what Ethereum calls optimistic rollups, but with proactive auditing schedule that is cryptoeconomically secure.
So they're effectively like verifying the state of each rollup as it submits its data in real time, and then communicating that to all the other ones?
I mean, essentially, like Polkadot splits its validator group into a number of different subsets, many different subsets. Each subset acts as a roll-up providing group. So they accept inputs. They, in their subset alone, determine what the effects onto the L1, quote unquote, right, the Polkadot relay chain, or the jam chain, of those inputs are, and they stake. They throw their stake behind that claim. Now that on its own, along with fraud proofs, would constitute an optimistic rollup, right? Now the difference with Polkadot is that validators also have two other jobs. One of them is that they erasure code all of the data that is needed to reevaluate that claim. And the second job is that they collect, they self-select for a random set of claims. They recollect all of the data that is needed to reevaluate those claims. And then they evaluate those claims and provide a signed statement on the validity of those claims. And because they self-select in a cryptoeconomically secure manner, we can gain absolute confidence that a particular a claim, or indeed a whole set of claims that constitute a single block, are correct.
Got it. So I guess my last question is, once they've verified
Thanks for your time.
this, is this in fact synchronous or is it asynchronous? Because they verified the information from the previous blocks from all the parachains, post that to the main chain, and then all the parachains are able to read that information. So is that in fact asynchronous? Because it's like on a block by block basis, the parachains that read that information from the previous block, once it's been certified and put on the main chain?
It's pipelined. So in some sense it's asynchronous. But the point of Jam, so with the Polkadot relay chain, so Polkadot as it stands, what we end up with is a series of, a set of parachains, each parachain apparently synchronous, because it's just providing each block in turn, in order, to be verified, right? Similar to how rollups, like OP stack rollups on Ethereum would work. The main thing that Jam brings is a coherent DA layer, and a huge one that is like many orders of magnitude bigger than anything that other ecosystems have to offer, which allows different cores, so which is essentially kind of different rollups, sort of, all to access the same data, right? Now this in and of itself doesn't solve a synchronous composability, but what it does is it provides the raw ingredients to solve it. So Jam itself doesn't provide a particularly scalable, synchronous, composable environment. But what can be built on Jam, because it has this basically decentralized data lake that is similarly accessible regardless of which computational element you are in, which rollup you're in, does allow it. And the reason it allows it is because if a smart contract lives in one parachain or one L2 rollup as opposed to another, it's synchronously composable with those in the same rollup, but not with others in different rollups. Well, in Jam, everything lives in the same data lake, which means when you want two smart contracts to be synchronously composable with each other, you just make sure that they're co-scheduled with each other, which is to say they're each placed on the same rollup at the same time. And then they can talk to each other as though they were in the same environment.
So is it kind of like what you're saying that because the data lake is accessible and connectable in real time, even if the validators don't necessarily verify the same, like you could schedule something at the same time on two different parachains, they can look to that information. It might not be verified until the next block, perhaps across both chains, but it's available for people to look at in real time? Is that what
the main point is that we don't have parachains, right? So smart contracts no longer in the Jam model of the world. We can implement parachains, and that's fine, and we will.
You don't even need parachains anymore.
But we don't need parachains. They're not a fundamental. They're not first-class citizen anymore. In Jam, we have this distributed data lake, which is accessible to all cores, right? All rollups. Rollups are really a bad term because they mean two different things. They mean both a blockchain with its own data, right? That exists sort of and sort of stamps itself onto an L1. And then also it means just a way of scaling computation into an L1. Yeah, and just it happens to be thus far, the means of scaling computation into an L1 has been by implementing a blockchain with its own data, right? Its own very particular piece of data, set of data. With Jam, we relax that, and we only mean that second thing, the idea of scaling computation. The data that the computation can draw from is the same for all of the quote-unquote rollups, or In Jam, we call them cores because they're quite similar to CPU cores. Just as a CPU, like a modern CPU processor, has, you know, I don't know, umpteen cores, 16 cores, 32 cores, and it can draw data from the same RAM, right, the same memory. In Jam, it's the same. We have 341 cores, and it can draw data from the same distributed data lake. And this means that, like, it doesn't matter. Like, smart contracts are not tied to parachains anymore. They just exist in this data lake. And when you want them to synchronously compose, you bring them together into the same core and let them synchronously compose. Yeah? And when you don't need them to synchronously compose, you allow them to exist in different cores.
So, I think that I understand it's a different primitive, to clearly to roll up is what you're trying to describe, with like a shared data in a different and meaningful way. I guess what I'm trying to understand is, I'm over here in core 1, 2, 3, doesn't really matter, I'm just somewhere, I just want to deploy a contract. Like, how does, like, you're saying I can deploy to any core or roll up at any given time, and it's not persistent?
I'm saying when you deploy, you don't deploy anywhere except into Jam. Like there is no persistent sharding. There is no persistent partitioning,
So
right?
it's one mega
Yeah.
roll up kind of. So
It's
not a
one.
roll-up.
It's a data lake, right? It's one big memory, one big chunk of storage, and you put your stuff in there, your smart contract or whatever else it is that you're doing. Jam doesn't make a distinction, right? For Jam is literally a machine. It's a computer. Now the clever thing about Jam is it's a very, very big computer, and normally big computers are not very coherent. Like, they have to do things to manage, as I was saying earlier, to manage their coherence. Like, and the way that we did this in Polkadot Relay Chain, the way that Ethereum is doing with its various L2s, and the way that it will presumably do it when it copies Polkadot 1's architecture, is to separate everything up, partition everything up into different roll-ups, different strands, right? Each with their own data, their own storage.
You have to move the data and et cetera.
And if you want to move the data between them, or heaven forbid, synchronously compose data between these strands, you're screwed, right? It's a huge, huge effort, if it's possible at all. With Jam, we remove that. Now, we can't remove that and pretend that nothing's happened, because then we will break the universal rule that you cannot scale and keep full coherence. So how do we manage it? Well, basically we say, you still have to have some incoherence, but you get to choose the incoherence on a block-by-block basis. You get to repartition your state, your global, grand, multi-petabyte state on a block-by-block basis. And this is the clever thing that Jam allows.
So, okay, and we're almost there. What you're saying is that there's no roll-ups, there's no way to communicate between roll-ups because that notion doesn't even matter. So we don't need to verify work over here to work over there. It's all one shared data and state machine, if I understand
Yes.
correctly? And so, okay, so then I guess the question is, so it's, you're saying on like a block by block or a choice basis, like how do you get around the fundamental problem that a giant state machine, like handling all the computations of all the demand in the world, how it can do that efficiently on a distributed network, right? Like it faces the same limitations as any network, if I understand correctly. So that's what I'm like, what is the innovation?
Yes. So the innovation is that we are agile about how we partition state. We cannot just have everything always be interactable with everything else. That breaks the size synchronicity and antagonism principle, right? So what we do is we say, every block, every 6 seconds, the machine is reconfigured. Yeah? And different bits of its state make it their way into the computational elements. And then eventually they go through their computational elements, pipelined, and eventually the implications of that computation are expressed in the core at the center, right? Without all of the data footprint, because it's that data footprint which causes the size synchronicity antagonism. If we get rid of the data, if we distill it down into just a little bit of implications, we can actually bring them into a synchronous environment. But we have to do that. We have to take the large amounts of data, partition it up, funnel it through these computational elements that can do very high performance computation, distill it down through these elements into a small amount of data, and then bring it together, right? This is what the join accumulate machine is. The join accumulate bit is taking the output of all these computational elements and accumulating them into a single state, right? This is why we still have synchronicity. But to get the scale, we take the large data lake and basically split it up. But we do it on a per 6 second basis, not on a persistent, unchanging basis that parachains and that Ethereum is now chasing.
So is it somewhat similar to like the ICP model with canisters, in which if they're not paid attention to for a while, they could like be removed from state because the system only pays attention to the relevant state?
Sort of. Well, okay. ICP keep their architecture pretty under covers, right? Like there's a very closed architecture, so I can't really comment too deeply on ICP. The concept of there being transient state is one that Jam honors. Like you cannot just indefinitely build up state, right? Eventually your validators will run out of hard disk space. And so data that enters into Jam's distributed data lake will be dropped after 28 days. And so you have this 28-day period whereby you do something with the whatever data is, the smart contract or whatever data is in the data lake, or it will be lost. So this concept exists, the concept of transience. And there's nothing that prevents you from like doing computation on a smart contract and sort of keeping it in the data lake, but you have to kind of pay for that computation, right?
So it's like an app. Let's say there's an app, right? And it's like I deposit X amount and I'm lending, I'm getting some yield, but nothing happens for 28 days. Like I'm at risk of that disappearing unless the app itself subsidizes the transaction. Like, I'm assuming that the app is fairly easy, right? But like, so something like that in which there's like some kind of incentivization scheme in which the apps or the users would pay to keep it relevant with the state. I'm sorry, I'm going so deep.
Realistically, there would have to, yes, realistically there have to be some sort of crypto-economic incentive to keeping that app's data around. Now this is, you know, if an Ethereum L1 model of, well, the app's data stays around indefinitely once they've paid a single fee is obviously nonsense and is not sustainable. So, you know, I don't, yes, indeed, you have to pay some sort of fee to keep the data around, and it's an ongoing fee,
I
right?
guess it's like it's so different than the roll-up-centric model. So I think for someone like in Ethereum or Celestial Land, right, it's like, what's happening? I don't get it. But like, I think I fundamentally now understand what you're saying is a difference. Because it's like, and there's certain trade-offs to either design, right? I just had never read any of the papers or nothing, so I'll read more later.
So tune in next week where we talk about stringing multiple Jam accumulate machines together in an intergalactic Jam grid. What's your name? Stephanie? That was awesome. Thanks so much. Let's give it up. You gotta go.
All right.
Your messenger did a good job as well, but I think we got there in the end. Gav, you gotta hit it. Yeah.
Split, yeah.
All right. Thank you so much. That was awesome.
Cheers, Jay. And,
all right.
Cheers, Stefania.
Thank you, everybody.
Cheers, guys.